Hello, everyone. Hello, hello, hello. This is Mr. Castillo. Welcome to another day. Today is Monday, February 8th. And if you're watching this, that means either you were absent or you're trying to just go back and maybe just refresh yourself and rewatch the lesson so it can, so you can get acquainted with it. So we're on slide one. Oh, I don't know what slide we are on. Sorry, 54. I don't know what's that one. We're on slide 54, and we're going to be using the law formulas to predict the strength of forces. So we're actually going to do the same thing we did last week, but now we're doing part two. So we're actually going to solve now, okay, for now. So we go to slide 55. Here's the schedule for the week. We got Zoom classes today and tomorrow, and then we have assignment number 6, which will be due on quizzes this Sunday. And we have office hours as well this Thursday from 9 a.m. to 12 p.m. in case you need some extra help. Okay. Here's our objective for today, Monday. Physicists will be able to apply the law formulas by finding the strength of forces in real world situations that honor Black History Month because it is February, the month for Black History Month. And with that said, I'm going to lean on. And our Black History Month highlight will be Mae C. Jemison, a physician and former astronaut. She became the first Black woman to go to space. She boarded the space shuttle Endeavour in 1992. First studying to become a medical doctor, which she accomplished in 1981, Dr. Jemison decided to take a risk and change her profession. She applied to the NASA program and was among just 15 people to be accepted out of 2,000 applicants. So she was literally in that top 1%. Super crazy and awesome. Once she boarded the Endeavour in 1992, she stayed in space for about 8 days conducting experiments on weightlessness and motion sickness since she was a doctor after all. Ooh, I should put a close parenthesis right here. Boom. And soon after her historic accomplishments, she accepted a teaching position at Dartmouth College, and she is alive today, actually. She's about 64, I think, 64 years old. And here's a quick bio video of her life in case you want to look at that as well. This is what we're going to be focusing on, which is very appropriate because we're all talking about gravitational fields, the magnetic and electric fields. And it's all about, the strength of these forces and she was in space, which is a big part of one of our energy fields. Let's go ahead and do our do now. For our do now, all I'm asking is you to drag the definition to the correct variable. Okay, and questions to keep in mind, which variable is from Coulomb's law and which variable is from the law of universal gravitation. So let's go ahead and do that at this time. Awesome. So your do now should look like this. We have M1, which is the mass of the first object, M2, mass of the second object, R is the distance between both objects, G is our gravitational constant, then we have Q1 is the quantity of the charge on the first charge, Q2 is the quantity of charge on the second charge, then this R is the distance between both charges, and then K is our Coulomb constant. So this is our do now, okay? Now let's go into our notes. And in our notes in slide 59, this is our notes we're going to take. But we also have slide 60 right here, which is a table that we're going to use as well. So we're going to use this back and forth, okay? So let's get started with our notes real quick. So using the law formulas to solve problems, part 2, we're adding one more step, and that step is step 5, find the final answer, remember the unit. So we're actually going to solve the answer. We're actually going to solve the problem by getting an answer. Step 1 basically just says is read the problem and highlight keywords. So problem is the average distance separating Earth and the Moon is 3.84 times 10 to the 8th power meters. Use the data in the table below, which is this data table right here. Use that table below to find the gravitational force between Earth and the Moon. Table is located on slide 60, which, like I mentioned, is right there as well. So we read the problem, step 1, and then we highlight keywords such as distance, the actual values, gravitational force, Earth, and Moon. Okay, so that's step 1. Step 2, pretty simple and straightforward. Identify which law we're using, Coulomb's or gravitational. Well, this problem is talking about the Earth, gravity, and mass. Therefore, we use the law of gravitation. Okay, therefore, we use the law of gravitation. Okay, the law of universal gravitation. Actually, sorry, universal gravitation. So we use that law because it's talking about Earth, planets, talking about gravity, and it's talking about mass, which is the main principle of the law of gravitation. Step 2 done. Step 3 is writing down the formula. So we actually have to write down the formula. So all you gotta do is in these little boxes, just write down the formula. Well, I know that in this formula we use Fg, so this is the force of gravity, equals the gravitation constant, and then you multiply the mass 1 times mass 2 over r squared. R squared. It looks a little bit funky, a little bit weird, but that's how the way it is. Don't let this confuse you. You can always go back to slide 48 so you can see the actual formula, which are right here and right there. Or you can also look at the past problems, and the past problems, they will also give you the actual formula as well. Okay. So as we go back into slide 59, we have the formula. So that's step 3. Check. Now we're going to go to step 4. Step 4 is plugging in the actual value. Well, this is where we actually use a lot of the stuff. So I'm trying to find the force of gravity, right? The gravitational force. So I don't know what that is. So that's still my Fg. So I don't know the actual value. That's still my Fg. Right here is the G, which is my gravitational constant, which I can actually go back and look at some past ones. And I can look right here, and it says that it is 6.7 times 10 to the negative 11 newtons times meter squared per kilogram squared. So I go back and I plug in that value because that's my gravitational constant. 6.7 times 10 to the negative 11 newtons times meters squared over kilograms squared. Like I said, it looks a little bit weird, but that's how it is. So don't let that freak you out. Okay. Obviously, if you want to make this a little bit better, you can always just go back and in the help section, you can put subscript, search for subscript, and you can actually find, oh, that's superscript, and find the value right there, and that'll make it easier for you. But I don't want to do all those steps, so this is good enough, okay? So that's my gravitation constant. Then we're going to M1 and M2. So M1 is the mass of Earth, and M2 will be the mass of the moon, because those are the two big objects we're dealing with. But how do we get those values? Well, you're supposed to use a table. So let's go to slide 60. Slide 60 has body, mass, radius, period, distance from the sun, and then this right here that's too complicated to explain. The cool thing, we don't need to use anything except these two sections right here, the body and the mass. So let's go with Earth. We know the mass of Earth is 5.98 times 10 to the 24th power. So let's do that. 5.98 times 10 to the, and I'm going to go to my superscript, just because now I'm kind of in the mood for that now. 24. But make sure you continue doing that, because go back and you do superscript again, so it can come back down kilograms. If not, it's going to stay up there, which is kind of weird. That's our first one. And our second one is the moon. So if I go down here, slide 60, the moon is 7.36 times 10 to the 22nd power. So what I'm actually going to do, I'm actually going to copy this. I'm pasting it here just because it's easier. And it said it was 7.36 times 10 to the 22nd power. 36 times 10 to the 22nd power. Beautiful. Right there. See? So we have mass 1 and mass 2, mass of the Earth and mass of the moon. Now, the last thing is the distance. The cool thing is they already tell us the distance between the moon and the Earth is 3.84 times 10 to the 8th power. So not as far as you think it is. 8. I'm going to make this a little bit smaller again, superscript. 8 meters, and then don't forget to square. We're going to square it, okay? So we're going to square it to second power. Awesome. Now that I have my values, that's step 4, plug in the values. Now we're going to go to step 5, and we're actually going to solve for it. So my final answer, or I can actually put the force of gravity between Earth and the moon is, and actually let's figure it out. So this is a law of math. You know, it's big, they're big numbers. So what we're gonna do, if we move to the right, there's some tips right here. Use this link to use an easy calculator for the law of universal gravitation, and then use this link to use an easy calculator for Coulomb's law. Okay, so which law we're using? Well, we know we're using the law of universal gravitation per step 2. So I'm actually gonna click on this, and it's gonna actually take me to a new link. And that's where I'm gonna plug it in. Okay, and once you go to that link, all you gotta do is just plug in this value, and you should be able to find the answer pretty quickly. So after I plugged in my values, 6.7 times 10 to 11th power of the gravitation constant times the mass of the Earth and the mass of the moon divided by the distance between them squared. And I got this. The force of gravity between Earth and the moon is 1.9 times 10 to the 22nd power newtons. And don't forget, that's our unit, newtons. That's how you measure force. In this case, force of gravity, you use the unit newtons. Okay, so take some time to copy this down as we move forward in a bit. Awesome. Hopefully you pause me and copy it down, because now we're going to slide 61. And slide 61, 62, 63, and 64 are all problems I would like for you guys to work on. And they have the same layout. We're focusing just on the law of gravitation. And the next day, tomorrow, we'll focus on Coulomb's law. So on 61, I give you step 1, 2, and 3. All you got to do is do step 4, plugging it in, and then step 5, finding the answer. Slide 62, I did the exact same thing, but now I remove step 3. So now you have to do step 3 and step 4 and step 5. And then 63 is the final one that I gave you only step 1, and you have to do step 2, 3, 4, and 5. So you see the little rhythm? And then the last one, in case you want a challenge, in case you thought that was easy, because it is easy, you want something a bit more challenging, here is a challenge question that's actually a college challenge, college level. College, oh, maybe I'll do that. Maybe I'll do that later. But college level challenge. And that's all the steps, and you have to figure out all the steps, and you have to do them, and then you have to find the answer. So let me know if you guys have any questions. You can GoGuardian me or email me or even message me on Google Classroom. I'll be able to help you out. Okay? Awesome, guys. Have a great day.